Check on
But like, what I can see is
All your search, bro.
what is it called?
I'm sorry, all your search,
Oh yeah. Yeah. Can you check if this audio?
are we good? Can we start? Yeah. Audio.
Speaking of audio. Speaking of audio. Oh, okay.
Sham, it's on you.
It's euro.
This is
No, it's a big topic.
He's like,
Yeah. I'm not doing much more today.
Hello, can I have everyone's attention, please? Hello. All right. Hello, everyone. Thanks a lot for taking up time to come to our session today. First off, we have a Slido. If you go to online, search Slido and enter this join code, you can send any questions that you want to be asked there. We'll have a small session by Jan, followed by which you can actually ask the questions here in person too. But if you're shy, if you don't want to ask here, feel free to put your questions up on Slido. I'll read a small bio of Jan. He has done so many great things in his life that obviously can't do justice to that. But Jan is a reference figure in AI and NLP who worked at Microsoft Research, Google Brain, and the Mila Institute. He co-authored papers with Yoshua Bengio, Jeff Hinton, two of the three godfathers of AI and the Turing Award winners. Jan is highly recognized for his research in machine learning. With over 10,000 citations on Google Scholar, he has a deep love for good engineering, holds a PhD in neural networks, and has a background in electrical engineering. With that, please give a huge round of applause for Jan.
All right. Thank you so much for the introduction and thank you so much for the invitation. Before trying my life as a startup co-founder, I was a university professor, so I would say that academia is very dear to me. So I'm really glad that I see so many young faces. There was a joke that the profs never get old; it's just the students that get younger and younger. So I'm really glad to be here. Thanks for the invitation. I did a little slide about introduction, not because I want to repeat it, but because I have a fairly short presentation, and then I hope that there will be questions, and I just want you to know what you can ask me. So if you want to ask me how the transition from basically academic life to startup works, feel free to ask. If you want to ask about PhD, feel free to ask. If you want to ask about stuff other than large language models, so other things I did. I was working on some speech recognition at some point, the classical one and the one with neural nets. So if you want to know a little bit more about this, feel free to ask me as well. I did some semi-supervised learnings on basically speech. So all of this is basically for you to ask, and then of course the other topics that I asked that you're interested about. So basically large language models and so on. Feel free to basically ask as well. But let's start with the maybe not so obvious ones. Let me try to be slightly closer to you. This works. And then a little bit of introduction about my company, because obviously I want you to try to use our tools later on. So a little shameless plug just at the beginning. So we are basically working on a framework for data processing, which should be fairly modern. So Python, but performance, so with a compile button in the end, and ready for writing some AI workloads. So we are actually teaching people to do LLMs in it, and if you try and basically find it useful, let me know. If you find it not useful, let me know. If you have, if you want to build something with it, let me know, and we'll try to assist you. With this little introduction, I would want to talk with you a little bit about how the architectures for basically using language models can work, and basically how this can be implemented. So I'm pretty sure that all of you have tried or have interacted with language models. It seems to be a very hot topic. But I can try to share with you a few of the findings of trying to run them both as proof of concept code, so little projects, and as in a sense trying to stabilize them and work with them as products. So it's an invitation to a journey. So we know where we are. We don't know what's in the fog, and we will try to basically get a glimpse into it. First of all, like every journey has to start at home, right? So we have to start with what large language models are doing. So they are perfect wordsmiths, like word processors. They are trained, so in a sense, they are called purpose of life. If we want to anthropomorphize, personify our own creations, they are trained to basically be very good at manipulating words, right? So the training goal of them is to predict text. It's a very rich medium. In a sense, all the questions can be answered with text, right? What's the purpose of life? And then the model can generate is P equal to NP, and then the model can generate. So if you get text right, you in a sense you get everything important right, because we can communicate with each other in text and can encode everything which is due to us as text. And the language models are the perfect tool to manipulate text in a sense. So they are really good at being able to reason with text, construct some arguments which at least sound plausible, use fancy words, and so on. On the other hand, they get this common knowledge that you can get out of reading all of the internet, the good and bad of it. They probably lack access to first of all, whatever is more recent than what they have been trained on. Second of all, whatever they don't have the access because it's not public on the internet often for good reasons. And they need to use tools to access this, right? So it's going to be a tandem. It's not only the large neural network, which is the AGI, but it's basically the neural network plus some tooling. And in this sense, the most basic tool that we'll spend some time on today is retrieval. And the most basic application of this tool is basically this four-step process. So whenever you want the model to answer a question for you, right, you start the search process, and then you construct the prompt out of the facts returned by the search process, right? So you basically construct a little riddle for the language model, which says, given that, and here goes your fact, dear language model, please tell me if. And the model answers or no, but basically the last part will generate an answer. And this is the most basic usage of a tool, where the tool is used first, and then the language model can access the prompt, so it has access to this knowledge and starts to generate. So we prime the model to finish a fairly large sentence or a fairly large block of text, something that they are trained to do, right? To basically continue on a given prompt. And there is this dichotomy between the two systems. So there is the retriever and the LLM, and in a sense they behave differently, right? So we can start with saying that the retriever deals with the world of fact, of knowledge. It's a database of sorts, and then the LLM deals with reasoning, and somehow together they create a solution, right? In other words, the retriever would be memory, and the LLM would be the processing unit. So just like we have a CPU, and the CPU can do the basic operations of a CPU, like pretty much addition, multiplication, conditions and so on jumps. So it's the LLM, but it needs data on which it operates and is the memory. So in this sense, in an AI application, the role of memory is the role of the database. So of the retriever, and the role of the language model is to say what needs to be fetched from the memory and then do operations on it. It can be a one-step process, it can be a multiple-step process, right? But there is a separation of concerns. And I would say that there is also a huge difference in the way those two things are created. So a database, yeah, it sounds old school, right? But it's something engineered, programmed. It's a very nice subject to teach. You can do students on it, right? There is the algebra on relations. I don't know whether you've learned it yet or no, but basically it's you can prove something, right? You can make claims like, I don't know, searching in a hash table is O of 1 and searching in a tree is O of log n. So it's actually a word which we feel very competent about, right? Because we can formulate word post theorems, prove them, and we know how the system works. So it's, in a sense, it's simple to us because we understand it. It's programmed, it's algorithmic. On the other hand, the LLMs and how we get them to do what we want, they are not really programmed, right? We don't know how to program a system that will talk to us, so it's learned. A lot of what they do comes from on which data we were training them. So with the language models consuming a large part of the internet, I guess that the choice of what they are, so what kind of architecture is secondary to what data they have been trained on. The behavior is complex. We don't really know how to influence it. And it's learned. So we control what's happening only indirectly. And whoever tries to basically get the LLM to produce an answer in a format, you know that it's not even programming, it's begging the system to do something for you, right? Please be concise. Please answer yes, no. And half of the time it will start with, well, it's complicated. So let me do a little elaborate first and then say a maybe, not a yes, no. So these are very, very different realms. And if you ever want to do something which is practical, then the world of simple program algorithmic is your friend, right? You know how to fix bugs there, you know how to basically do an SLA, so a guarantee of how the system will perform. In the LLM world, at best you can say, on my data this behaves in a good way, and then you never know what's going to happen when, say, a new usage pattern emerges. And then this is transferred to how we can maintain the system. So databases are really good at basically getting new data, forgetting old data, updating data, and so on. So if someone comes to you and says, okay, this individual asked to be forgotten, you know what to do, right? It's a deleted, and that's it. On the other hand, in a sense, all the research on how to secure large language models, how to make ChatGPT not be racist or not talk about how to build a bomb and so on, it's answering the question how to perform a delete on the language model, right? Because somehow it got the notion of, say, racist jokes. Now, if people are able to get them out of the system, it means that it's really hard to delete this information. In fact, you don't delete it, just try to hide it. So any update, it's fairly easy to add new information, at least in a small amount. It's actually quite difficult to add new information, not destroy the model. There is something called catastrophic forgetting in neural nets. If you have a net trained on a data set, and then you start fine-tuning another data set, at some point it forgets the original task. With the large language models, it will get tough because the usual strategy is you train a little bit on the old data and then a little bit on the new data. That's a solution to this catastrophic forgetting. But here we don't really have the data sets, right? Everyone gives an API, but no one gives the data. The data is the secret sauce of LLMs. So the updates, fairly easy to add a little bit of new information, using fine-tuning, really difficult to delete information. Pretty much an open research topic called AI safety right now. This is deletion. And updates are even harder because the model tend to have the old information associated with some context and then will resurface it in new ones. So it's basically the two words, engineering and alchemy of sorts. And then the last distinction may be slightly different. The first dots are about how the system feels like. last one is a little bit how it works in an application. So usually the database is maintained as new facts arrive, as new data is available, right? So you typically implement it using either a batch process or some continuous updates. This is what Pascal tries to solve. But you implement it basically when you have new data, you do something to your database to store it there. The LLM is usually used when you have a question. So the app has two parts. There is the part of let's store the data inside of a system, which is done when new data arrives, the retrieval, and then there is the part of the work that we do whenever a question arrives, and this is the readout part, and this is where we use the LLM. It's basically really hard to pre-compute answer to all the questions. But we can try, and this is what indexing does, right? Indexing tries to do some proactive work such that this answering is easier. And we, as engineers, can shift the boundary between the two parts. And we can talk a little bit about how to achieve it. All right. And we will focus today a little bit on the retriever. So first of all, the retriever, if you read a cookbook on the internet how to do it, most of the time people will start with a vector database. I guess it's because the neural nets internally they are implemented using vectors, so it feels right to use a vector search. A very, very simple observation is that it's actually usually better to use something good for retrieval, like basically the classical information retrieval things that you maybe are still taught. So basically posting lists, scoring functions, TF-IDF, BM25. Because sometimes people just want to be bothered to answer a question based on a keyword, and you really want to match the keyword. And it's really tough to make a system wait for soft reasoning and synonymous matching and so on. And you do something based on the keyword. So for instance, I don't know if you follow the Google Gemini model and the needle in the haystack benchmark. So they were saying that the model supports it, and the benchmark is very easy to implement with regular expressions. There is a body of text, and you have to search for a phrase, the magical number in the magic city is, and then you have to retrieve the number. It's really easy to solve this expression. It's a very programming task. To force a neural net which does the soft reasoning to solve this programming task is the hard part. So sometimes a very basic retriever works well, and sometimes you want to have something else, like for instance, you want to formulate your facts as a knowledge base, right? So entities, relationship between them, and do a search in this. And all of this is nicely algorithmic, so there is more than just vector search that you can use. But there is a little bit more in the retrievers, and you can ask a question how they compare to language models. Because if you want to make a chatbot, so something which answers questions, you can do a very bad one with just a retriever. At some point, a few years back, we did one which was just for a joke, a chatbot which was using Reddit. So you have basically conversations of Reddit. You can create a corpus of questions and answers, and then you retrieve a question, you print back the answer. It's bad. I cannot say it's good. It's bad, but sometimes it's nice. It maintains some sort of a conversation. It's nowhere near what the LLM do, but a pure retriever can maintain a bad conversation. On the other hand, if Google is a retriever for information, right, what's Perplexity AI? It's a language model which acts as a retriever. So the two can be, in a sense, the same, right? Both of them serve a very similar purpose, which is that of answering questions to your user. So what's the relationship? And are they basically very opposite? Do you do them separately? They tend to be used differently. I would say that there are a little bit complementary, and there is this yin-yang relationship. So a good retriever knows about the language model, or perhaps uses it for preprocessing. A language model has to use this retriever and has to have some retrieval, and in fact, scaling language models to have those non-complex will require some sort of retrieval mechanism built into them. In a sense, this attention, which is in the basic log of transformer, this is a soft approximation to retrieval, so a soft approximation to searching using a table scan, the most primitive form of search that you can come up with. And if you think from an engineering perspective, just like applications that we build have databases, and it's an open question what's the separation between the two. So the databases somehow they grew to have procedural languages, so you can put part of your application inside of the database for performance. And then if you have an application, sometimes you want to use an embedded database also for performance. So making fast applications, especially right now, there is a revisited discussion where to draw the line between a database and application, because you really want to have the two in the same place. And I guess that the same would be happening with the relationship of the LLM and the retriever. So you can have it separate, but then you want to reduce latency, so you want to have it together. And then you want to have a smarter retriever, so it does a little bit of language processing as well. And then the LLM, maybe you want to save money, so it does a little bit of retriever, and you keep on merging the two. So it's not separate. And in fact, a very simple thing that we did at some point is we made the retriever a little bit aware of the LLM just to see what will happen. And it's a very easy way to, let's say, save on costs. So you change the basic scheme of retrieve factor and construct a prompt to take one piece of information, run it through the LLM. If it answers the question, you're done. If it doesn't answer, take more facts and do it the second time and then do it the third time. And on the average, it answers really fast, right? So on the average, you retrieve just a little bit of information and you run it with a small amount of information, so it's cheap. Sometimes you pay a little bit more, but on the average, it's cheaper. And this is a place where the two worlds meet in a sense. The retriever works with the LLM, tries to supply as many facts as needed and not more to optimize cost. And if you do an application, of course, you want to optimize cost and you don't want to pay that much for an API. So bringing those two together is beneficial. And this is what I believe will be happening. So if you will be designing the new applications of AI, it will not be the separation first, then with the reasoning, but it will be more like a CPU, right? It gets some data from the memory, then does some processing, then gets some more. And to basically easily write this, you will need tools that allow you to do both. So to allow you to index the data and maintain the knowledge base, and then do a little bit of this query answering, and then maybe rinse and repeat, right? So have the cycle as a and the LLM will be using indices, and the index will be using LLM just to be aware of it and prepare the data properly for the LLM. So it's going to be complicated, and the tools that you use have to support this complexity and support you in this complexity. And this is in a sense what we do at Pathway, and do advertisement time. If you ever want to code a system, it basically reads different data sources and then maintains this in real time, and either sends it or allows you to implement this query and response loop. We believe we are a nice tool for it. So please try us out. You can implement most of those schemes in just a few lines of code. So we provide building blocks to say, read the data, and this can be static files, this can be files on a shared drive, and so on, to do that data in real time. Create an index out of them, whether you prefer a classical index or no, and then assemble this with the LLM for an application which basically updates in real time whatever knowledge you put into it. Please check this one. Check this out, and we are also trying to break the or go a little bit beyond the chat sort of interface. The chat interface suggests that there is a conversation most of the time. It's not like this. So very nice. You can prototype a lot of interactions in AI with spreadsheets, because this allows you to do those multiple steps of reasoning in a very friendly environment. So for instance, it's very, very easy to do something in parallel for many inputs, then do a little summary, then do some other step of reasoning and explain how it works. So spreadsheet interface, I believe, will kick out the chat interface where you try to have those multiple paths of reasoning and then merge them together, but don't really have a way to do it. So I guess that the the search for better UX for AI will be happening, and I just want to open it a little bit, and then basically I guess that we will be figuring out how to properly architecture those systems, how to tie together the retrievers and LLMs, and also how to do it in terms of basically application engineering. So one lies on the CPU, does conditional computation, if branches, and so on. The other one is more on the GPU, so dense computations, no ifs. I don't know how many of you are familiar with how a GPU works, but it really doesn't like the if statement. Usually executes both branches. But you want to bring those two to basically optimize latency and cost, and people will want it. Yeah, no one wants to wait half a minute for an answer from a computer. We are past this at this moment. And basically, I would want to invite you to take the journey and maybe start a discussion, because as I said, I can tell you a little bit about my path, and also if you have projects to do, I can tell you how I would be doing that. So with this, I would want to open the question.
We have a couple of questions on Slido. Perfect.
Maybe we can basically switch to Slido.
Yeah.
It's maybe easier.
Yeah.
You said that.
Maybe when Slido works, there's a question in the room.
Sham.
That's a very good question, actually. Well, it's pretty spontaneous with my PhD application. At some point, I learned that I can do it, and I decided, okay, let's do it. I was lucky to do it right when the neural nets were taking off. If I had a chance to do it the second time, I would probably be more deliberate about it. So try to figure out more when I was an undergrad what I want, as opposed to, okay, there is an opportunity, so let's take it, but then I guess you need a bit of black and white. Sometimes you don't know what you really want, and that's what is right. It's easier to make sense out of life than backwards. But especially in the US, you have to start preparation for the PhD earlier than and then find a good advisor, because it's a few years of work with a person, and it's work, and you are alone and so on. So you really want to have a good advisor and find a topic that you're passionate about, because you're going to need it, because it's a few years of work and getting paper rejections and so on. So if you don't have this willingness to solve a problem, you will burn out pretty fast. But it's worth it. Oh. So maybe it's better right now. So any other questions from the room?
Thank you. Yes.
Oh, you have it on the slide. Okay.
It's not shared for some reason, but I can read out those questions.
Yeah.
I can show it.
Okay.
Yeah. So the most popular question is Pathway hiring? And how can people apply for internships or full-time roles there? Do you have something to say about that?
We are. Find me on LinkedIn. Actually, the first and last name combination is pretty unique, so it's probably the easiest way to get you out of the crowd.
Okay, sounds good. The next question is: can you discuss any specific applications or industries where Pathway has had a significant impact, and how do you see its potential expanding in the future?
Okay. So with LLMs, we are trying to target the legal market. Legal texts are are basically, on the one hand, it's human readable text, right? And so on the other hand, they have lots of structure. So there is a video basically learning the structure. And then you also want to you actually have to do some document processing. Even simple things like if you ever have a contract in legal matters, usually you don't rewrite the contract, just do annexes to it, right? So at some point you have to merge all of this. It's pretty much like a manual and a human language working with this and without proper revision control. So legal documents look like basically people reinventing patches and merges and, and all of this, but without tools. So I guess it's a good ground for the LLMs because it's language, structured language, and it's a use case where it's easy to have an impact because there is also code needed.
Right. Thank you for sharing that. The next question is, looking ahead, what excites you the most about the future of data processing technology, and what role do you see participate in shaping that future?
So I would say it's all about speed, right? We tend to like that your website goes fast and so on. So why would we want to wait for a day, say, between new data becomes available in a system? So for me, the nice thing about Halfway is that you can easily code for like the static web case, so the one which we are familiar with, just code your data processing as you were writing a batch process, and then it takes care of the updates. So you get the reactivity for free. Sure, on a small task, you can solve it by running the batching very, very fast. But at some point, this is just wasteful. And we are trying to take this waste away.
No problem, I'm not involved.
Next question is, what advice would you give for anyone interested in pursuing machine learning research as a career?
I guess do a dual path of learning. So try to do many hands-on projects because machine learning is a very, very applied discipline, right? So it's closer to art than science in many ways. So hands-on projects are important, but then also read the basics. So it may seem like LLMs are basically all of the work right now, and there is no need to go back to say linear regression, so Gauss, or to the old ways of doing machine learning, because basically there's the new thing right now, AI. But I guess that many things are fairly similar. It's just easy to basically test on your training set and get good results and so on. So get a good grasp of the basics and understand the problem domain. So read the basics, perhaps skip the middle part, and do hands-on projects because it's a very, very applied domain. Also, try to implement things from scratch. I guess that there is more to be learned if you try to implement a small thing by yourself than learning to use basically somebody else's code and get good results, but without an understanding of what's inside. Especially if you want to pursue a PhD. There is basically a lot of things that you only learn when you do them yourself. And then they are obvious. And it's not so obvious when you just use tools that other people do.
Next question is, also can everyone maintain silence? People in the back are not able to hear. So, thank you. For machine learning, is theory important, or is the knowledge about the application of ML enough?
Well, there is scarce theory which, but I would say that it's important because it gives you some bounds on what can be achieved. Domain knowledge is important because if you want to make useful tools, they have to basically solve real problems. And a lot of practical work in machine learning is the application of pretty much the same tools, but to new domains. But theory is important because you understand what's happening. It's an empirical study, right? So, for instance, p-values, which is a theoretical concept, right? But how do you know that your new model is better than the old one? And honestly, looking at conversations gets boring pretty fast. And deciding whether something was better than last week or whether you're just happy in life is also tough. And there are tools to solve it, like really, really easy statistical tools. Like say you do pairwise comparisons, and there is the ELO scoring. It's using chess, right? But it's also you can also use it to score models. It's actually a very nice model with a few Gaussians, right, and p-values inside of it. And if you know it, you can I don't know, do it. So a funny say story about I had a friend who worked for NVIDIA, and they were doing ETS systems. And all of the evaluation is you have to listen to the samples. And at some point he said, well, it's just like ELO. So he implemented the tool, and it's got a very, very popular tool. It's really easy to score systems. So know the basics, know how this works, because it's just Gaussian. And otherwise it's your blind.
Thank you for answering that. The next question is, the tech landscape is changing so incredibly fast. What advice would you give to undergrad students like us to stay ahead of the curve?
Well, I would repeat myself. Learn the basics. So if you understand how, say, any programming language works, but in depth, if there is a new programming language, it's not that hard to map from one to another. If you really understand the old one in depth, if you have this in-depth knowledge, it's better to have an in-depth knowledge of one thing than to have a superficial knowledge of many new shiny toys. So I know that it feels super overwhelming right now with AI, because every day there is a new language model, but in fact they are fairly similar. So you don't have to look at this. It's maybe better to implement something on your own and understand, like for instance, what is the cost of this, right? Why people are fighting with, I don't know, so you have the transformer, like understand why the API is priced this way it is, right? Why, how it scales with the amount of data, why it's hard to scale it one way or not the other. This would come from you trying to implement a few things, as opposed to basically reading who released the latest language model. The other heuristic is that basically if something was relevant for, let's say, 20 years, it probably will be relevant for the next 20 years. So the theory, especially the old theory, will be relevant for a long time. Many new things will pass also very quickly. So play with the new toys, but try to get a very good understanding of the basics.
Thank you for answering that. The next question is, what motivated you to start your own company, and what were some unexpected barriers that came along the way? I guess the question is more of the side of like academics to entrepreneurship.
So the motivation will be to do things which is more than just writing papers. So at some point you write papers and you are stuck into a paper writing mode. So for instance, for papers, you would usually have a fixed data set and iterate on the model, because that's how everyone does it. And you know that it's better to basically grab more data, but it's hard to get a paper like this because it's tough to compare. And it's not super practical at some point. So going out of the trying to solve a real world problem is important part. And maybe challenge, something that I understood is that solving real problems that people have is more important than doing things which are nicer or theoretically nice. So at first I wanted to come up with things which would be like, you really need a deep theory to implement something, and it turns out that no, it's important that you solve someone's problem. The deeper problem you solve, the better, not necessarily the technology that solves it. All the technology has to be there as well, but it's much more important to concentrate on the human and his problems than on the technology if you want to do a company.
Right. Sounds good. The next question is, somebody wants to become a CTO. Do they need to do a PhD? What's a good career path to become a CTO?
Well, no, I don't think a PhD is required. As a matter of fact, many good CTOs don't. It's a role where you have lots of interaction with people. So you have to like people. You have to know how to communicate. So another advice that I would give to myself is write more essays. Because in the end, you have to communicate with other people. You can have the best idea in the world, but if you are not able to communicate with other people, you will not do it. And CTO actually, it's about managing people. And to manage, you have to show them the way. To show them the way, you have to be able to describe it. If you don't know how to write, you don't know how to basically describe what you want to say. It's just as long as you have nothing to say. So if you do research and you solve a really tough problem and you cannot describe it, someone else will come. But writing is helpful, because you have to convey it. It's better written papers basically get more readers. But if you want to manage people, or if you want to manage a company, you have to be able to show to people your ideas basically. It's like a virus that you put inside of their heads. If you don't know how to do it, then you will not do it regardless of your technical capabilities.
But apart from that, writing papers, arena of like PhD, that point where you actually focus on this one problem for like multiple years, does that add some value in your current position as the CTO?
Well, I guess that doing your company would be similar to doing a PhD in the sense that you are trying to do something sensible for a longer period of time, going to burnout, and there is a struggle to it. And you have to be somewhat broad because, well, in a PhD you can change topic, in a company you can pivot, but also you have to do one thing in the end. So it helps to have some large surface area of potential topics and then do one in depth.
Okay, I think we already covered this question. So we get to how can I start learning LLMs and related topics on my own?
So for LLMs, it's really easy to get started and play with them. You can start with tools, and then actually I would try to implement them. So basically saying there are those things which work really well behind the APIs and so on. I can get intuitions on what's possible, but then if you want to understand what those tools do, try to implement them in a way that they will work on your computer. Sure, it's not going to be that good as GPT. But for instance, a very easy LLM to do is you take a few songs, I don't know, rap songs or hip hop songs, and try to generate like a lyrics. And they are funny. It's like a fun project and you can do it and it's doable on the laptop.
And on that note, for folks who are asking how can I start learning LLMs, we'll share more about this soon, but JSC and partner collaborating on an exciting bootcamp come AI tech hackathon. So that will be a great opportunity for you all to learn about it. But you'll find out more soon. Oh, there's so many questions. Kind of. Okay, we can answer a few more. What background knowledge is needed to learn about RAGs? What are the first steps I can take? I think pretty much answered that already.
It's a mixture of basically classical algorithms, how you search it. So algorithm 101, binary tree, and some knowledge of
Yeah. Okay, I'll switch to this question.
Okay.
What does your day-to-day look like at the office as a CTO? How different do you think it is from a CTO of a non-startup company? Like medium size or large size?
All right. So if your company is small, you're doing everything, right? It means that you have to have a little bit of high-level vision where this company is going, and then you end up doing the coding. So you are spanning vertically all the way from basically coding, doing reviews, to coming up with solutions and strategy. If the company is large, you only the strategy part. I guess it's fun as a small company because you get to do everything.
Okay, next question is, what are some tips that you have for us undergrad students who are about to enter the tech industry?
The projects that you are passionate about. Try to really solve something with the tools you are learning to, because that's what it's all about. It's about solving problems.
Got it. Next question is, any advice on being able to efficiently read and understand academic papers?
It comes with practice. Probably reading books is a very good place because a book is a distillation of ideas. So reading books, it's a good entry. Then there are survey papers which try to distill knowledge in many papers. And then I would probably look into research groups, and they very often publish list of papers, so list of recommended reading, and start reading from it. Because there is a deluge of papers, and many of them will be very incremental. It's good to basically find a research group which does something similar to what you do, and try to go through the reading list, and possibly start the reading list. So reading papers is much more efficient with other people, and basically just discuss it.
Got it. Next is, when you figured out that you had more than 10,000 citations on Google Scholar, how did it feel? Was it surprising? Was it like, yeah, of course I can do that?
No. When I was finished my PhD, I wanted to have more than say 20. On the other hand, it's a long tail effect. So you always have that one thing which somehow is good and it's much better than the other things. So it's the same with citations. I guess I have one paper which made most of them. And when I wrote it, I was excited about it. And then I tried to do other things and it was more frustrated that I cannot repeat this.
Got it. Next question is, what were your favorite resources or book recommendations for learning machine learning research?
So I really like the classical books. Bishop book, which is pretty tough, but covers the basics really well. It's Goodfellow Benjamin deep learning book would be good, but it's more basic. So I would start with this and basically not be shy about the more technical books or the more theoretical ones, and then implement it.
Okay, that sounds great. I skipped a couple of questions earlier. Let's quickly cover them too. What got you interested in the world of AI, machine learning? Probably how did you figure out that you want to move PhD?
It's just exciting that you can make a computer think or try to make a computer think. It's really exciting that the machine that is in a sense very brain dead and good at following those very detailed instructions suddenly can do a high level task. And you don't have to figure out how to do this high level task. This is extremely exciting. That basically you can get a machine to do things you don't know how to do, but you don't know. It's okay. I don't know how to say multiply 40-digit numbers, but I know how to write steps for it. So in a sense, it's whereas with machine learning, you are solving tasks that you don't know how to properly solve. And this is the exciting part. That in the end, the algorithm knows something that you don't. You can try to discover it out of the algorithm, analyze it, get new knowledge out of it. It learns something that you didn't.
Sounds great. I think I missed this question earlier. When creating Pathway, what kind of user base did you have in mind? Learning beginners like us or industry experts?
It's a very good question. I'm afraid we have the middle ground out of it, but we try to correct ourselves and make it super easy for beginners, but have some depth. But when the beginners start to be intermediate and then senior and so on, they still have something to do. It doesn't saturate at the beginner level.
That's the safest answer to keep both the crowds happy also.
But we are concentrating right now to be easy for the easy tasks. So. And doable for the hard.
Sounds great. I also made this question. Do you mind showing us an example of how we start using Pathway? If you want, you can.
But no, it's actually if you we actually have many examples. So if you ever want to get started, the easiest way is you just go to developers. And one thing we try to do to be super easy that many things that are here are actually runnable. There is code on GitHub, and many of the things should be runnable in Colab. So there are links to Google Colab, so you can basically start in your browser. Sometimes it's in the text, sometimes it's more obvious, so it should be. Like there is just a link. So you just go to the getting started, and this is all runnable code. Every snippet you see, it's runnable code. So. For the LLM, there would be also showcases and LLM, and we have some starting points for doing language models. The latest that we did is, for instance, models that you don't have to run in the cloud, right? So local models.
And as I already mentioned about that AI tech hackathon that we are coming up with, you'll have a detailed boot camp to run you through how to use the technologies, how word vectors and then so on. So that's also a good way to go. I think this is the last question. I'm good at coding, but not at communicating my ideas. How would you suggest I develop my communication skills, since that may be very important in the future?
Blogging. Trying to explain this. I don't know how good an idea is to try to get an LLM to code this for you, because you actually have to express it in words as opposed to writing code. but anything which basically transmits your idea to some other entity using words. It's super important.
All right. With that, can we give a huge round of applause for them? So pretty much we'll open food right now. Feel free to grab food. We have Domino's pizza, drinks, snacks. Yeah, after 5 minutes, once we set all those things up. Feel free to network around, feel free to talk to them if you want. And everybody, don't forget, May 11th, DevFest, TLC. Use find more information about our Instagram in the upcoming days. Thank you so much, everyone.
Thank you.